So as you can see, these are textbooks. Even though it's a worksheet, these are from the textbook. So once again, before you come to class tomorrow, you should have already checked as you're going along, as you're doing the homework, checking these to make sure you're doing them correct. Don't show up and say, I hope I did them all right. Very easy to check. All right. So what we're going to be examining here is graphing square root functions. And where do the square root functions come from? Why are we concerned with it? How is it tied into everything else? Okay. So, pretty basic that we've already solved and looked at everything that has to do with quadratics. So all we're going to do is, once again, switch x and y, solve for x, find its inverse, which comes out to be plus or minus square root of x. So you actually get two functions here. You got one square root of x and negative square root of x. So if we look at both the inverse and the original function, f of x and f inverse, so I can graph x squared. We know what that looks like. What happens when we graph the inverse of that? That would be the square root of x. And also the negative. We need the positive and the negative to actually have the full inverse. Okay? So if you do that, you can see you just get the parabola on its side. Or it's just reflected over, once again, just like yesterday, it's just reflected over the diagonal of the graph. So if you take the parabola, let me zoom out a little bit. Yeah, that's a little bit easier. It's just reflected right over the diagonal. We're just taking y equals x squared, reflected over the diagonal here, and we get this, which is technically x equals y squared, or plus or minus square root of x. So what you're going to be doing is really, you're going to be graphing a lot of square roots, but I could say graph all the quadratic inverses, and that's the exact same thing. So these are all quadratic inverses. Okay? Quadratic inverses. Now, the big idea here, eventually, I'm going to give you the big idea, and then we can look at the smaller pieces and mechanics. But you remember, back here, absolute value, if we always had our functions that looked just like this. And then we said, well, when there's a number inside the absolute value, what does that do to the graph? Okay? That moved it left or right, inside the absolute value. If there's a number outside the absolute value, what did that do to the graph? Up and down. And if there's a number in front, what did that do to the graph? Okay. Skinnier, wider for positives. If it was negative, what did the graph do? It went down. Okay. And then again, we saw this with quadratics. So if we had a number not inside the absolute value, but inside the parentheses, what did that do to the graph with vertex form? Well, it moves the vertex left and right. And the number outside moved the vertex, or y-intercept, up and down. Same exact thing as it did with absolute value. If we change the number in front, the a value here, what did that do to the graph? Once again, made it skinnier, wider, and then if you went negative, it opened down. Same exact thing. And then we went over to, just recently, we went over to cubics. We kind of saw the same process. We didn't really go into a vertex form for cubics, but it operates the same way. Okay? So it becomes skinnier, wider, and then it can flip. When you go into negatives, it flips, just like everything else. Okay. It's going. And we can even go way far back to one of your favorite functions of all time, step functions. Alright? And we did this one first, but now looking back at it, I'm sure now you've seen all the other vertex forms and everything, you could say, well, if I just know the parent graph, I know what this looks like, and I know what happens when I change this number right here, okay, that just moves the whole thing left and right. I don't really have to regraph everything and see how, well, let's see how this one looks if I just know what these numbers do to the graph. Once again, the y-intercept just moves up and down. And once again, if I change the number in front, what did that do to the graph? Made the steps bigger, okay, smaller. If I went negative, what happened? Went downstairs. Bigger, smaller, positive, negative. So all these all together, absolute value, quadratics, cubics, greatest integer step function. Hopefully all those you can see that, well, if we know how to write this equation the same way, basically, one might have parentheses, one might have absolute value, or one might be a step function, but the same numbers in the same location do the exact same thing to every graph. That's an important, big goal we want you to understand by the time you finish Algebra 2, is that it doesn't matter what kind of function it is. The numbers do the same thing. So instead of a absolute value step function parentheses, now it's just a square root. But the numbers will do the same thing. So if we have a number inside of the square root, what will that do to the graph? It moves it back and forth. Okay. If it's, well, I already had a negative, but if it's positive, you see that it opens up. And you see if this is negative, it opens down. Just like a parabola, it would open up and open down. Remember, this is just the inverse of a parabola. So it's really a parabola just on its side. So it'll behave in a similar way. You can kind of look at this and imagine, well, this is the same shape as a parabola. It's kind of going towards the vertex. Just everything's rotated. The number on the outside is still the y-intercept. Just moves it up and down. So knowing all this information will make any graphing in every single math class a lot easier, because you're not really starting from scratch every time. What you start from is here, right? And you just say, well, where was this graph going to move to? How will this graph move? If this is a -5, how does that move the graph? If it's a +5 on the outside, how does that just move this graph? So you're not really moving or regraphing, you're just moving each point in different directions. Okay? So before you graph anything today, I want you to think about, can you use the information of what you already know from every other graph you've done all year to kind of give you a mental picture of what your graph should look like? Okay. So you don't have to know exact numbers. I'm not talking about numbers, but I'm saying if it's a negative in front, you should pretty much already know it should be opening down. Okay. Just like with a parabola, you knew it was a parabola opening down. Absolute value was opening down. If this was negative, every single time that number in front went negative, it opened down. Okay. If there's a number inside, it was always the opposite. So if this number was like +2, it really moved it left 2. Okay. If the number on the outside, though, was +2, that just was regular move it up 2. Okay. So be thinking along these lines and really relating it to everything else we've done so far, and realizing it's opening up might look different for a parabola and a square root, but really it's kind of the same thing. Opening up, opening down, opening up, opening down, opening up, opening down. Anytime this is negative in front, we know what that number does inside and so on. Okay. So, but at first, to really make this stuff intuitive, you really need to do just old-fashioned, plug in the numbers, see what you get. Okay, so let's go ahead and start. Let's do a few of these together. I'm going to talk about domain as we go along. You can see here we have some domain issues, meaning you can see how the graph just kind of starts right here for the x values and then goes up, gets bigger, and also starts right here for the y values, and it just gets bigger. Okay, so there's some different domain issues. Before it was like domain was always all reals, and now we're going to have some restrictions on both the domain and the range. Okay. So the main thing, why do we have this new restriction with square roots? Okay, even though we just got done with taking square roots and negatives, we still are not going to be graphing square roots and negatives. So the reason we have the restriction is that we cannot have any negatives inside the square root, meaning this has to be 0 or positive. So let's start on your worksheet right now. And what you're going to do for every problem, it just goes in general, we can even write it above here, write the name. How do you get the domain? Okay. You're going to take whatever's inside the square root, okay, whatever's inside the square root, set it greater than or equal to 0, because inside the square root you need 0 or positive, bigger number than 0. Right? Then solve, if possible, if necessary. That's going to be your domain. That's also going to let you know where to start on your t-chart. It's crucial that we start at the right point. So for all your t-charts, what you don't want to do is put random numbers in here. You want to actually, this is a strategically chosen point, your first x, strategically chosen point, and then we're just going to add 1. We're going to go up. I guess we don't have to add 1, but we do have to go up. We don't want to go down because it's not going to be in the domain. It's always going to be greater than, so we want to go up. So for instance, on 9, we'll take whatever's inside the square root, which is 3x, set it greater than or equal to 0, solve. What is x? What is x equal to or greater than if you solve this? Divide both sides by 3 and you get 0. So your domain is just all x values greater than or equal to 0. And again, this number right here and this number will always be the same. So you need to do the domain before the graphing. You need to know where to start your graph. And then from there we can choose some numbers. Okay, and you can go up by 1, but you can really choose any numbers up to 10 because the graph goes up to 10. So if you want to go 0, 1, 2, 3, 4, 5, but maybe break it up just so we have a cleaner graph, we can do, let's see, how about just 1, 3, 5, 9. Why not? And then 10. But we can pick any points. I just want to get points all over my domain of my graph. I don't want to graph just 5 points right here and then have it blank over here. And now here's the calculator part for some of the points. Plug in 0. 3 times 0 is 0. Square root of 0 is, okay. 1 times 3 is, square root of 3 is 1 point. Okay, 1.7. 3 times 3 is square root of 9. 5 times 3 is square root of 15 is let's see here. Square root 7 times, no, sorry, 7. 9 times 3 is square root of 27. What is it? 5.1. Okay. And then 10 times 3 is 30. Square root of 30 is 5.4. All right. And you can see with these decimals, it'll be estimating. We're not going to obviously graph 1.7 exactly, so that's why we're only rounding to the tenths. So we got 0, 0. We have 1, 1.7. We have 3, 3. We have 5 and almost 4, very close to 4. We have 9, 5.1. And then 10 and 5.4. Now, what is the shape of this graph? What kind of shape is this? Curved. What kind of curve? Same as what other graph? Parabola. Yeah, this is a half a parabola, right? So as you're doing this, just think about this should have about the same shape. So what happens if you get a shape that's not half of a parabola? You did something wrong. Yeah, don't do one of those things where you just connect dots and say, well, I connected dots, so that's my graph. If it's not a parabola shape, okay, something's up. So just think of, like I said earlier, we could say graph the square root function, or I could be saying graph the quadratic inverse functions. These are all inverses of quadratics. Now looking at this, where do the y values start? So you're looking at only the y-axis. Where do they start on this number line? 0. Okay. And do they go up or down? Up. So up is greater than or equal to. So I'm always looking at the y-axis only, seeing where it starts. It doesn't have to cross the y-axis, but I'm just looking to see where it starts. So it could be way over here. It could still start at 0. And then it'll go up or down. Alright, so just review. First things first, you've got to do domain. Solve for domain. That goes down here. And then you take whatever number that is. It's the same number that you're going to start with on your t-chart. You've got to start there. Okay? Despite saying this, I've seen people, they just want to go down and do the same exact points for every graph. It won't work. Your graph will be incomplete. So we don't have the luxury of symmetry, or it's a straight line. So it's not like absolute value or quadratic where you only have to do part of it and then you get the other points for free. Or, yeah, like quadratics and absolute value. So we have to use all the points. Okay, as I mentioned before, what do you expect 10 to look like, given that there's a negative right here? Yeah, it's going to be like a parabola, but opening down. So it'll be like this graph, but opening down. And this one's going to be a 5x, so yeah, it'll look a little different. So we already kind of have an idea what it'll look like before we start. What's the domain? Yeah, so take inside the square root, greater than or equal to 0, solve. So we get what? 0 again. There's our domain. Go ahead and start at 0. Count up. Don't have to count up by ones. You don't have to be perfect on your increments. It's not going to change anything. Let's go down to 13 and do the domain. What's the domain on 13? Okay, so x plus 2 is what? Again, this means I need inside the square root to be positive or 0. I need this inside to be 0 or positive. It can't be negative. That's why we're choosing greater than or equal to 0. So if you solve this, yeah, you get x is greater than or equal to negative 2. So this time we need to start at negative 2. And you might recall what happens when you start adding subtracting inside here. What does that do to the graph? How does it move it? So the number inside, how does that move it? Yeah, so you can expect it before you graph it. Oh, that's just going to be like this regular old square root function, but it's just going to be moved. Is it 2 to the left or 2 to the right? How will it move? Okay? That's the kind of thing you want to start getting used to. That this won't be like starting all over, but it'll just be like the regular old square root of x, just moved a certain way. We can go down here. Let's go over here, actually, 14. What's the domain of 14? X must be what? Greater than or equal to 7. Add 7 to both sides. Okay, so we need to start at 7. And since that's already so close to the end and it's greater than, we only have 7, 8, 9, 10. So 7, 8, 9, 10. So plug in 7. 7 minus 7 is 0. Square root of 0 is 0. So this graph is going to start at right here. So remember, it's a minus 7, but it looks like it moves to the right 7. It moves to positive 7. And then it starts. You plug in 8, you get 8 minus 7 is 1, so we get 8, 1. 9, 9 minus 7 is 2. Square root of 2 is 1.4. And 10, 10 minus 7 is 3. Square root of 3 is 1.7. So what is the range here? Okay, looking at the y, looking here only at the y-axis, where does the graph start? 0. Okay, and does it go up or down? Goes up. Okay, goes up. And there's your range. So I'm just using this example because some were confused that, well, it doesn't cross the y-axis, so that means there's no range or something. Don't confuse the range for a y-intercept. You're just looking to see where does the graph start. Question?
For number 13, since the first x is -2, don't we have to go through negative numbers, like for the rest of the x's, or does it just have to
The first x is 0.
for 13?
Oh, 13. Oh, yeah. Yeah, so you're going to go up by 1 or 2. So your next number should be like -1, 0. And we don't want to just have the points right here, so maybe like 5 and 8. Kind of see what happens over here. 5, 7, and 9. Just so you can get a better, wider spread of points. But yeah, got to start here. Got to start here, and then it's greater than -2, so we got to go up. Okay, on the back, it no longer asks you for the domain and range, but what do you still need to do in order to start the problem? What's that? Yeah, you kind of need the domain because you need this number, right? So you still have to do it, but maybe by now you can see this. Oh, that's going to be -4 because -4 plus 4 is 0. So yeah, maybe -4 here. Over here you can say, I guess if x is 2, 3 times 2 would be 6. 6 minus 6 would be 0. So my domain will start at 2 and go up. But you still need to do that calculation to know where to start your graph. Okay. Good. A good quiz question, if you're thinking, what would be good to know, would be 17 and 28. Why 17 and 28? Okay. Because they have a number on the inside, a number on the outside, so you can really show me that you know a number on the inside is just moving the graph this way, and a number on the outside is moving the graph this way. So if you know this information, you can find the range without even graphing. If you know it's a +5 outside, range is y greater than or equal to 5. So how do I finish the test so fast, still get the right answers? It's by understanding this bigger picture stuff rather than, well, I got to make a t-chart and see what the points are and see what it looks like. Okay, so be thinking of course, the details, get them correct, but eventually you want to see the bigger picture. It's the same process as it was for every other function we've done so far. Okay, so go ahead and work on that the rest of the period. Not too long, but maybe long enough to ask you a few questions if you need them.